After we found the link between cosmic rays and clouds, we only knew that it was a total cloud cover, but I had to find out what type of clouds. And at some point it became possible with a new data set to investigate exactly this. And at that time I got help from Eigil Marsh.
Yeah, I sent that figure to
He helped analyzing these data. And much to our surprise, we found that the link is actually to the low clouds. So it seems as if cosmic rays are changing low clouds.
All right, I'll speak to you later. Yeah, bye. Bye.
And that is very, very good news for the whole idea. When I got this result, I thought the correlation was much better than I ever dreamed of.
If you decrease the amount of low clouds, it will be more heating down to the ground. And in particular now this new work that shows that it's only the low clouds that changes, which makes it very interesting. There's still a mechanism to explain this that's missing, and it's now important to do the research to try to understand this mechanism.
So there's a fairly large fraction of low clouds. A large part are responsible for a large part of the cooling caused by these clouds. The reason low clouds are so important is that they actually reflect a lot of the sunlight back into space. I mean, we know them when we travel in airplanes. These are these monotonic scenes that we see over the oceans. And they are white because they are reflecting the sunlight back into space. And you can imagine if you change the amount of low clouds, you change the amount of energy that the surface gets. That means that low clouds have a strong cooling effect on the Earth's climate. So if we have more low clouds, climate will become colder. And if we have fewer cosmic rays, we have fewer low clouds, and the Earth becomes warmer.
You mean with the ISCO data set? Yeah. It's in the infrared, what we've been looking at.
That's interesting. Okay. Well, I first heard about Henrik Svensmark's work when we became interested in looking at how aerosols, or very small particles, are produced in the Earth's atmosphere in the first place. I mean, this is important because all clouds are formed upon aerosol particles that are in the atmosphere.
So the satellite is looking at a specific parameter.
In terms of the work that we've done, what we've found is that the galactic cosmic rays are capable of modulating the aerosols, or small particles, in the lowest part of the atmosphere. In fact, we can show that the aerosols produced by galactic cosmic rays are significantly modulated in the lower layer, which contains these clouds that produce a cooling effect on the Earth. What we don't understand at this point is exactly how and why they're formed. Every cloud droplet that's formed is formed on a particle initially in the air. And so it's absolutely crucial to understand how these particles come about and what their properties are. Otherwise, we can't ever hope to understand clouds and their behavior.
And that's where cosmic rays actually might come in. Because what do cosmic rays do when they enter the Earth's atmosphere? They produce small ions. Oh yes. So it is the belief that these small charges help forming these small specks or aerosols in the Earth's atmosphere.
Whereas most people would think that since there's water in the atmosphere, that naturally there'll be clouds, but that isn't true. The only way that clouds can form in the atmosphere, in our atmosphere, under normal conditions, is to condense onto an aerosol or existing particle in the air. Every cloud droplet that's formed is formed on a particle initially in the air. All clouds are formed upon these aerosols. And so it's absolutely crucial to understand how these particles come about and what their properties are. Otherwise, we can't ever hope to understand clouds and their behavior.
In science, it's not enough just to have a good theory. You also need some experiments to support the ideas. I was very determined to get an experiment that could show that we had this connection between cosmic rays, aerosol formation, and clouds. What I'm going to talk about is cosmic rays. These are particles, or very energetic particles. They enter the Earth's atmosphere and we can actually measure them. So when we have maximum activity, you see that there's not so many cosmic rays coming in to the Earth's atmosphere. That's because now the sun has a very strong magnetic field, and it's difficult for the particles that come from the galactic space to get into the solar system. So there seems to be an agreement between changes in solar activity and changes in climate. So what is really needed is some experimental evidence that can say yes or no whether such a relation, how does it really work? That is what is needed. And it's very fortunate that such an experiment looks like will be performed.
I would like to say I think the experiment is completely misconceived and shows a complete lack of elementary knowledge about how the clouds behave. So whichever way you look at it, that experiment is completely misconceived and will tell you nothing about what happens in the atmosphere.
Well, I totally disagree, but I should say that the people that are involved there are people that are experts in aerosols and atmospheric chemistry, so they know what they're doing. So, and I know, they will disagree with your point of view, but it's true there are different views, but you are one extreme, I would say. I've many times given talks where people have got very excited and very strongly trying to tell me that what I was doing was completely waste of time.
Have you read my book?
Well, I know of your book.
Well, there you are then. You shouldn't argue with me on cloud physics. No, the whole thing is a complete misconception.
Not a single one has come up with anything from a scientific point of view that made me think that there was not something, a real scientific question worth pursuing.
So, what's the point of doing that experiment?
Well, there's been written several papers where they discuss where do the cloud condensation nuclei actually come from, how are they formed.
Oh, we know that.
No, it's not known, according to these persons.
Oh my God, well they just must read the literature.
I had this theory, so I decided that we should do an experiment in Copenhagen that could show whether my idea was right or wrong. Unfortunately, it turned out to be much more difficult than I thought it would be. I actually started this without having no funds at all, and I just continued hoping that we would get money at some point. Building the laboratory, building the experiment, getting the funds, it actually took almost 4 years. The idea in this experiment is to investigate what is the role of cosmic rays. And the idea is that we in the end will be able to mimic the processes that are going on in the real atmosphere. So